So let's see this combinatorics problem from AMC 12A 2006. This is the problem number 24. It is asking us to find the number of terms in the expansion of a plus b plus c power 2006 plus a minus b minus c power 2006. So this involves the concept of multinomial theorem or multinomial expansion. To understand multinomial expansion, let us try to analyze the expansion of a plus b plus c whole square. This is very easy. A plus b plus c whole square means we are multiplying the expressions a plus b plus c twice, which gives us the terms like this: a, ba, ca, ab, and so on. If you look at it, each term is basically a two-letter word which are made with a, b, or c. And we are doing it without any restriction. We are creating two-letter words by selecting any two letters of A, B, and C. And you can notice that the letters can repeat as well. Like we can use both of them as A, or both of them as B, or both of them as C, or maybe any two of them, like there can be different as well. So without any restriction, we are just creating each term are two-letter words, and we are taking all possible combinations of this. So using the same idea for the expansion of a1 plus a2 plus a3 up to ak whole power n, which is the generalization of the multinomial expansion, we can say each term of this expansion would be a n letter word as we are raising it to the power of n. So it will be a n letter word made with the letters a1, a2 up to ak. Now let's say for a specific case, we have x1 number of a1, x2 number of a2. In that particular term, we have x1 number of a1, x2 number of a2, x3 number of a3, so on till xk number of ak. And we can understand that as this word has to be a n letter word, so this x1 plus x2 plus x3 up to xk should be n. Now let us see how many times for this specific case where we have x1 a, x2 a2, x3 a3, how many times this type of word reappears in the expansion. So it's nothing but number of ways of arranging n objects. We have n objects, but x1 of them are identical because they all are a1. They all are identically a1. x2 of them are also identical. They all are a2. Similarly, xk of them are identical and they all are just ak. So how many times this appear? It's basically number of ways of arranging n objects where x1 of them are identical, x2 of them are identical, and so on up to xk of them are identical. And we already know that sum of these xi's should be n. Now we know that very easily the coefficient would be n factorial, means how many times they appear. We know that how to arrange this kind of n objects. It's n factorial over x1 factorial times x2 factorial, so on till xk factorial. And each term would contain x1 number of a1, so there would be a a1 to the power x1, a2 to the power of x2, and so on till ak to the power xk. So this particular term would appear this many times. So this has to be the coefficient of this term. Okay. Now how many terms will be there? You can understand whatever the non-negative integer solutions of these equations are, that many terms will be there. So we are trying to find out that number of non-negative solutions of this non-negative integer solutions of this particular equation. And using the stars and bars principle, we can very easily say that number of such non-negative solutions would be n plus k minus 1, choose k minus 1, n plus k minus 1, choose k minus 1. Now why is that true? Try to think about it. Maybe we can discuss that same concept in some other videos. Number of terms in this expansion would be number of integer solution of this equation, and each term would look like this. So this is basically the expansion of this thing. Now using the same idea, we can say expansion of a plus b plus c whole power 2022 would look like this: 2022 factorial by x factorial times y factorial times z factorial times a to the power x times b to the power y times c to the power z, such that we know x plus y plus z would be 2022. So number of terms using the same idea, it would be 2022, which is our n here, plus 3, which is our k here. So because number of terms is k, so 3 minus 1 and choose 3 minus 1. So that would be 2024, choose 2. So this many terms we have in the expansion of a plus b plus c whole power 2022. Now let us see how many terms will be there in a minus b minus c power 2022. It's very simple. The number of terms will be again the same. But if you look at the expansion, the terms would look like 2022 factorial over x factorial, y factorial, z factorial, a to the power x minus b to the power y minus c to the power z. Now our required expression look like this. So we want a plus b plus c whole to the power 2022 plus a minus b minus c whole power 2022, and we know this is the expansion of a plus b plus c whole power 2022, and this is the expansion of a minus b minus c whole power 2022. So now if you look at it carefully, that when y and z, they are of same parity, means if they both are even or they both are odd, then we get like this minus would just vanish and this minus would also just vanish, and we will get a plus sign here. So the terms will be exactly same and they will add together and the coefficient will just become double, right? But when y and z are of different parity, then one negative sign would come here and the terms, the numerical value of the terms would be same, but they will be of different signs and they will cancel each other. The terms will cancel each other. Now, if we can find out that in how many cases y and z are of different parity, so we have to subtract that many cases from the number of terms in the expansion of a plus b plus c whole power 2022, which was 2024, choose 2. So if we can figure out how many cases are there where y and z are of different parity, and if we can subtract that number from 2024, choose 2, we would get our required answer. So that will be all for this video. And if you want to get the full solution, visit the link given below.